Good evening, fellas. Good evening, fellas. How's it going? Monday night. About year, as we say in Northern Ireland. What the fuck? Saludos. Thank you very much. Hope you're well on this Monday evening. Not been working too hard today. In the UK today the clocks went forward, which means that it stays nice and sunny outside for much longer, which is great for me because I like it when it's nice outside. Okay, I am fully expecting this to be a flipping headache because Rockford often are sometimes a flipping headache, so we shall see whether I get lucky or not. Oh man, do I really have to take the side panels off for this? I don't have to do that. Looks like an old cheap CD drive. Yeah, I can kind of get that. Who still uses a CD-ROM drive in their PC? Is that that size? Nope, too small. Oh man, I think we're gonna have to. I'm going to have to take the side panels off. Ah, dang it. Okay. Hunter likes the oldies. Wicked. Yeah, I thought this would be a good one to live stream. Like I said, I fully expect this to be a headache. So I don't necessarily expect for us to be able to repair this tonight on the live stream because it uses parts that I probably don't have, yeah. But we'll give it our best shot. We'll give it our best shot. I'm gonna have to take these side bits off. Greetings from Germany. How's it going, bro? What's up? Oh, it does come out. Ah yeah, there we go. Oop, there it is, and out she comes. So without the side beauty panels, this thing is a lot smaller. Look, baby little thing, teeny little amplifier. See what's going on with this. Okay. So yeah, who still uses CD drives on their PCs? Someone said this looks like an old CD drive. Like ancient CD drive, which I can kind of get that. Oh, this is the world's longest screw for the RCAs. Right, here we go. Finally going to get this thing apart. Okay. Come on. There we go. Okay. Ooh, lots of SMD components in here. Oh man, this camera keeps spazzing out. Come on. Come on. Work. There we go. Now she's back in business. Right, there we go. Zoom in on this a little bit. Okay. So, yeah, pretty cool. This... Oh, wow, look, check this out. Is that a... that looks like a crossover board, perhaps. See, I'm not so familiar with these old Rockfords. But there's a small board here in some headers. Looks like it's reversible. Looks like you can flip it around, but yeah, I don't think that's going to be the issue. So, I spy the issue. See that? That's all smoked up. So we have some FETs that are smoked up that we need to look at. Ah, no. These are the same. These are the same as what the Phoenix Gold Tantrum used. I hate these things. I'm not going all the way out into the outside to get my socket set just now, so let's just see if we can quickly do that with this. There we go. Yeah, that'll be fine. I cannot be bothered to go all the way to get my socket set miles away. Oh, I hate this shit. Why they just use some normal screws, man? Why have they got to put these flipping weird nut things on? And they're done up so tightly as well. You have to hold the pressure on them for a bit. What we got going on live chat? Oh crap, I need to move some of these wires out of the way of my pedals. Been falling everything over. Right, here we go, what's going on? Relatively easy amps to repair. You can get schematic, which makes the things easier. Yes, it's a crossover card. That was a good guess. That was a cool guess then from myself. Not much in it. Yeah, it's a small little 60.2. Stuart Lloyd, how's it going, buddy? If I have not missed something, I've seen you do a lot of diode checks and such shortly after powering down an amp. What I haven't seen is how you discharge or measure the caps first. Yeah, I'm always discharging the caps. Every single time I turn an amplifier off, I pretty much got my my dummy loads here. So these are, oh, bloody hell, these are what I use when I'm bench when I turn the amplifier off, and I need to make some readings. So yeah, these are 4 ohm, 1000 watt each. So I usually series a couple of them up. So I give an 8 ohm thing, and I just go boof on the rail caps, and it just discharges it pretty much instantly. So hey, Mr. Francis is watching. How's it going, my friend? How's it going? How's your build going? When's your next video? Fucking hate these things. Yo, what's up to Big Stone? Seth, how's it going, man? Pull the head of your screwdriver and see if it's the same size. That's not a bad idea, actually. I had not thought of that. Oh, holy shit! Yes, my friend, Seth. That is fantastic advice. I had not even thought about that. I had not even thought that might actually work. It is actually the same size as the hex style attachments that go in the screwdriver. Awesome. That makes my life a whole lot flipping easier. Thank you very much to Seth. No flipping way. Yeah, boy. Just literally shaved like half an hour off this repair. I wish I'd known that when I was doing the Phoenix Gold tantrum. The tantrum flipping. That was a headache to take apart. Okay, what we got going on here? So this isn't one of the Rockfords that sold as the fetch to the thing. I have got one of those somewhere. Where have I put that one? I think I put it on the shelf. Yeah, I'm doing a Rockford repair at the moment as well. I'm doing a punch series, 1500, which is a lovely amplifier. Lots of love for that amplifier. When I was live streaming, everyone was saying it's a fantastic amplifier, and I've got half of it working. So the output section, it's got two halves of output drive essentially. Yeah, it's almost a full bridge amplifier. It's not quite a full bridge amplifier. It works in a similar way to the JL Audio Slash series, the old 500 Slash and the 1000 Slash, the big ones. Works in a similar way to that, and also works in a similar way to Vibe Monobox 4. It has half rail voltage on each of the speaker output terminals, plus and minus, and then it swings an audio signal up to top rail and down to ground. Cool. Oh, that made my life a flipping hell lot easier. So yes, we have... Oh, come on, this camera. It's never been doing this before. Why is this camera now deciding to take ages to come back on? There we go. Deactivate when not shooting. Hello from Ukraine. Also amplifiers repair. Cool. That's cool. I had a P 400 times 2 blow on me for no reason. There's always a reason. There's always a reason something blows up, man. It's usually vibration. That's the reason. I've successfully repaired my Blaupunkt. Nice. This is old school stuff. But I blew my meter in the process, measuring the transistors and not realizing the cap still had 85 volts of charge. Yeah, that's a bitch when that happens. I haven't done that yet. I've not actually blown the meter just yet. But yeah, discharge, man. Always discharge. Should let them struggle with them all. Nah, man, come on. You know, you guys don't be sitting there for half hour whilst I do that. Good day. Now join what's new. Lots of new stuff. I've got lots of updates for you guys. If any of you guys are interested in flipping what I'm repairing and shit, I've been doing a lot this last few days. So I've had some good successes over the last couple of days, and I made one massive fuck up. I made one massive fuck up, and it really screwed me over. And that's in the amplifier repair sense. I fucked something up royally. I'm still hurting from it. Still feeling the pain. I still have those 3 amps here from last year to give to you. A loudest 1K, 75.2 and a 752. Yeah, man, bring them to Nats this year, innit? It's like a couple of months away. Yeah, just bring them to Nats. Or bring them when you want me to test your amplifier. I don't know if you still want me to do that or not. There has now been some YouTube dynos and stuff of it, so I don't know whether you still want me to do that or not. But okay, what other screws are holding you down, my friend? What other screws are holding you down? It could just be sometimes these, yeah, the FETs, they here we go, yeah, see? This old thermal pad, it gets properly, the FETs get properly stuck to it. Interesting, this is using IRF 540 and 9540. So usually we see the 640N and the 9640, whereas this is 540s and 9540s. I haven't seen these exact ones used before, but they'll either be a higher voltage, lower current specification, or a lower voltage, higher current specification. Going by the size of this amplifier, it's probably going to be a lower voltage, higher current spec. Actually, or maybe no, maybe it's a higher voltage, because we want, this thing needs to be able to do power at 4 ohms, doesn't it? So maybe. Okay, there she is, the teeny baby little board. Okay, just looking for obvious signs here. Anything blown on the bottom of the board, any traces perhaps. Seems to be bottom of the board seems to be intact. A bit of moisture, a bit of condensation there, but that's yeah, a little bit of condensation which you get on these old amplifiers. Constant cooling and heating for summer, winter, turn it on, turn it off, etc. Can cause issues. And this looks like the section that blew was in fact the power supply. I think this is a strange layout, and it's using very non-standard parts. So it's labelled up as Q7. Ah, here we go in Q6. So the parts which blew were 50. Ah, that's more like it. 50 N06. So this. Oh man, this camera. Come on. Why you do this now? You never do this. So yeah, you can generally get a rough idea. So these FETs here, these are 50 N06, which is very similar to ones I saw used in the Fly. The Fly amplifier, I think, used 50 N06. So this is a power supply FET, and it's only using 2 FETs for the power supply. So these got overloaded for some reason and blew. Now, they don't usually get overloaded on their own. Electronic components do just deteriorate over time, so it could have just deteriorated over time, or the output section could have blown and blew the power supply along with it. So we need to check the output section as well. Before we do that, let's remove these 2 FETs because they are quite obviously toast. Toast and marmalade. Toast and marmite. Cheers. Yeah, this camera's really winding me up. I'm going to unplug it and plug it back in and see what difference that makes. Good evening to Timmy. No, not Timmy. Timet Jock 70. Timet Jock 70. I'm sorry. I don't know how to pronounce most of the usernames on this live stream. My mids in my car install, Richard, are 6.5s. They're the Digital Designs audiophile A series. Yeah, the weather actually is getting much better, so I'll do a video on that soon. Oops, have the wrong soldering iron tip. So just want to wait for that to heat up, okay? This is actually pretty interesting. So, you know how manufacturers of electronic devices and electronic goods will deliberately make the unit run quite hard, or deliberately design some part of it that fails over a certain amount of time, so that you have to buy a new one. And that generally goes the same for light bulbs. So, LED light bulbs. LEDs, the actual light emitting diode, the actual raw component, can run for literally years and years and years and years and years. Many hours. LED bulbs can be manufactured to have a pretty much indefinite lifetime in your own lifetime. The technology exists for that to be the case, but obviously no one's going to do that, because if you buy an LED light bulb and it works forever, you're never going to buy another one. So that's not a very good business decision. So, these LED light bulbs I have here, these are the things which are in my floodlight that I have up here, which I just have pointing on the workbench to give myself a bit more light. So these are the LED bulbs that I have bought for it. As you can see, many of the actual LEDs are missing from there, because I've removed some. So all it is just a board full of LEDs like this, full of high power LEDs, and then inside the bulb you have the LED driver board for that, which contains, by the looks of it, some capacitors and some, well, mainly capacitors actually, but yeah, there's some other shit going on in there. I haven't pulled it out to check. So interestingly, I have got two of these lights here. Obviously one of them is not working at the moment. I've only got one hooked up, but I installed two of these bulbs at exactly the same time, fitted them in, and so both these bulbs have been running for exactly the same amount of time, like down to the second. They've been in together, they've been working perfectly together. Now, what's even more interesting is both of these bulbs both failed within 10 minutes of each other. What the fuck? It's almost like they're designed to fail at a specific set amount of usage time. What are the chances of that? Like, literally, the amount of hours that these have been on, I installed these like months and months ago. So, you know, we're talking about like 10 minutes worth of difference in thousands of hours. That is too close. That is too much of a coincidence. And they're both actually powered off of separate sort of drive things. They're actually run separately, so it's not like one died and then the other got more power as a result of that. Now, what I actually did, obviously, so one of them died and then the other one died. And I looked on the board here, and as you can see, all it is just a bunch of LEDs that are in series. And the ones that die get this little black dot on them. You can see there's like little black burn on there. So both of these bulbs had one LED that had a black dot on it. So what I did is I desoldered a fresh LED that didn't have a black dot on it, and I swapped it out, put it into the other one, and it worked again. But it only worked for 10 minutes, and I was like, oh crap, and then another LED blew. So obviously these LEDs are being run slightly too hard for like indefinite usage. So what I actually did, because they were dying every 10 minutes after I replaced, like a different one was dying every 10 minutes, right? So what I did was to make sure that this thing would work going forward and it wouldn't keep killing them, is I actually added some more LEDs in series. So you can see how I've added 2 additional LEDs in series, so that the overall voltage across each LED is well, it's not much lower, it's a little bit lower. So with LEDs, they have quite a sharp point where if you go much above that, then their lifetime decreases rapidly above a certain point. So I just added a couple more in series, which brought the voltage across each LED diode down a notch, but it was down enough to make them reliable. So after I installed these 2 LEDs in series, I've had this now running for 2 days, right? So the LEDs were blowing every 10 minutes with all the original number of LEDs in series. I added 2 more in series, and all of a sudden it works and it doesn't blow. So I reckon that actually these things are designed with the voltage on kind of really high for the LED diode, for the LEDs, and the design is that they die after a certain number of hours. So, you know, if I was to buy these again, I would, from day one, I would install like 2 or 3 more LEDs in series, which brings the voltage down. It doesn't actually reduce the light from it. If anything, I get a little bit more light, because yes, although each LED is getting slightly less voltage, it's not getting any less voltage for the brightness to be noticeable, but I've added 2 more LEDs. So if anything, it's actually brighter than it was before, and it actually lasts longer. But I do now only have one, because I've obviously salvaged the other one to be able to do that. But I actually can't. I was going to buy some more of these LEDs, but I can't find them. I have no idea what type these are, and they don't measure, they don't read anything on my transistor tester, and they have like no resistance. They just have an infinite resistance, so I have no idea what they are. Holy shit, quite a lot of stuff in the live chat. Do you repair Cactus Sound? We don't have Cactus Sound in the UK, so no. I've never repaired Cactus Sound because we don't have Cactus Sound in the UK. But Cactus Sound will use the same boards as pretty much everything else. So I probably have repaired a Cactus Sound, but just not with a Cactus Sound sticker on the front. Can do, man. You'll probably take the B2 away, as it might not take 0.3 all weekend. 0.3? Fuck's sake, man. Yeah. At ModNats weekend, I'm actually going to bring some. I'm actually going to bring my soldering iron, and I'm going to bring loads of spare components, because I imagine some people will probably kill some stuff at ModNats as they did last year, but I didn't bring anything last year to repair things with. So this year I'm probably going to bring like a little inverter for my car, so I can hook up my soldering iron, oscilloscope, and I'll bring all my spare parts, and so if someone kills something, I might be able to give them a repair then and there. Obviously that will only be on for simple repairs. I'm not going to be sitting there for hours all day at ModNats whilst everyone's enjoying the base while I'm sitting by my car fixing someone's piece of shit that they blew. But yeah, you know, the option's there. if someone needs my help, then it's there. Especially for waffles. If any waffle kills something, then man, I'll straight in there, soldering iron out, scope on, let's get this thing fucking working, man. Shut up. What flavour do you vape? Biscuity flavours. What's the best brand capacitors for replacing parts on an amplifier? There are many different brands of capacitors depending on what excuse me. Depending on where the capacitor is. If it's a bit large rail capacitor, then again it depends on the voltage that you use. I generally haven't had to do a lot of capacitor replacements, so I'm not too sure what the best brands are, if I'm perfectly honest. I don't want to send you down the wrong path by suggesting some brand, because I'm not too sure. I have not had to do that yet. Usually it's only on old school amplifiers. How's it going? Coogan, how's it going, buddy? How much are tools to repair amps? You can spend anywhere from like £300 to like thousands of pounds. It depends. If you buy everything used, it's not too expensive. You just need a good soldering iron, a decent scope, a small variable power supply, multimeter, transistor tester. I mean, this is a premium bit of kit. You don't need a thermal imager, but it really does help sometimes. Yeah, solder sucker, solder, screwdrivers. Sorry if I missed it, but how you ended with the 7K? The LANs are 7K. Let me know if you mean the LANs are 7K. We finally fixed the issue. It was a small glass diode on the by the gate resistor. That was faulty. It was open. So yeah, replaced that, and it works perfect. Call my car the ambulance. I like that. I like that a lot. That's a cool name, ambulance. Yeah, I like that a lot actually. That's pretty cool. I think ¿Qué falla tiene este ampli? I think that means what issue does this amplifier have? Blown power supply and possibly blown output section, but we haven't checked that yet. Sección de power supply tiene muchos problemas. Muy caliente. Y otras. Uh-oh, looks like... Oh no, that's a... wait, what the fuck? Oh no, that's a diode, that's fine. Do we have a dead output section? So I'm just going through it on... the camera's still doing the same thing. Oh, never mind. Crap. Wait, no, maybe not. Maybe not. I think the output section might be okay. Damn it! Damn it! I spoke too soon. The last FET that I decided to test. So we have a dead IRF 9540 here. You can see there's a direct short circuit between the gate and source. And gate and drain and source. So all three legs are shorted together. So that's a bugger. So, okay. So this amplifier then needs a replacement power supply. And it's gonna, well, the fact that this one's dead, so we're gonna have to replace, I'll probably replace both of these. Just wait for this camera to turn on. Oh, are you fucking kidding me? Why? Why you do this? Better. Right, switch between two. And it's black again. It never does this. Only tonight. So yeah, new needs a new 9540. Probably a new 540 as well. New power supply FETs. I'm going to put 3205s in there instead. And we also need to check these driver transistors, because these might be faulty as well if it killed the output section, the output transistor here. And when we fit the new MOSFET, we will probably need to rebias it using this biasing potentiometer thing. adjustment pot. So this is a Class AB amplifier, so we have a biasing potentiometer here, which we'll need to... I'll explain that later when it comes around to actually biasing this thing. Sam Young caps generally suck. Sam Young, they always die. Yeah, what the hell is wrong with the camera tonight? Camera's not happy this evening. Okay, alright, so I'm gonna suck the holes. Suck the holes. I do like a good suckety hole of the pads. Oh Jesus Christ! This FET got really stank hot. Look, that's gonna really piss me off. So yeah, this got really hot, and it's actually carbonized the board a little bit here, which may have made this section conductive, which is going to be a bitch. We have to kind of cut this out perhaps. And also there's a small trace here which has been damaged, and you can see I'm lifting the small trace there, and that is the trace that goes from the gate resistor to this FET. So maybe that gate resistor is also fucked. Let's find out. Let's just suck the holes first so we can put a new FET in at some point later. The funny thing is, the reason this amplifier probably died was because it was being used to drive a sub, and a crappy sub at that. Because I know where this amplifier came from, and I know that this would have been fitted in some 17-year-old Corsa powering some bullshit with no power supply behind it. Not that it needs it; it's a small amplifier, but it would have been powering some god awful knows what sub in bridge mode. And it would have been clipped to fuck. Whereas this thing needs to go on a nice pair of SQ tweeters, or a nice front end, maybe like a mid-range front end setup on the A pillar, like like a 3-inch mid and dome tweeter on the pillars maybe, or like a sort of low power but nice sounding complete front end door speakers. That's what this needs to be running, not a sub. Does this board look like it was designed to run a sub? Ah, el caballo, no man, don't want that. El coche no funcionaba. That's not good. The drivers in those Rockford amps often go powered up with the ground and remote to check the power supply waveforms. Ah, interesting. I didn't know you could do that with these. That's pretty cool. So just ground and remote, and you can check the waveforms. Cool. All right, let's do that. Actually, to be fair, I can do that anyway with the power, because I'm not fitting the FET yet anyway. Yeah. Okay, so we've got a TL494, and we've also got some power supply drive transistors somewhere on the board. So before we fit new FETs, okay, new power supply FETs. God damn it! Come on, give me a break. So before we fit new power supply FETs, let's work out where the driver transistors were on this amplifier. So we can take. I'm gonna just change where this camera is pointing at. Let's go down a little bit, and let's zoom a little bit more as well. There we go. So this is one of the pads for the power supply FET. So you can see leg number 1 is the gate. So the gate will be connected to the gate resistor, which is here. The gate resistor should be a 68 ohm by the looks of things. And if we go across it, it's not a 68 ohm, it's completely open, it's dead, so that needs changing anyway. But we can find, so where does the fact that that's dead means the driver's probably dead as well. So if we follow this trace back, it goes into this small hole on the board, which is over here. So it goes under the board, and then if we flip the board over, we can follow where it goes from there. So that's here. So then we go all the way over here to this small hole here. If we turn the board back over, then we can see that that goes to this small hole here, and this small hole here goes to this driver transistor. Okay, so these 4 are going to be our driver transistors for the power supply FETs. So, are any of them short first? Let's double check. They may have survived. Usually these go short if they die. Seems okay. Might have got lucky on the drivers. They could be leaking though, so we'll have to check the wave to make sure that the wave looks fine. Okay. So maybe that one's okay. Next thing I'm going to check is this very, very burnt area of the board over here, where the MOSFET died. I need to check that the board isn't conducting. Okay, so the board got burnt here and it's all black and it's carbonized. And sometimes if the board carbonizes, the board will conduct itself. So we put our multimeter probe on one area of the board, not on a trace or a pad, and then the other multimeter probe on another area of the board. We set our multimeter to the highest possible ohm setting, 2 mega ohms, so it's very sensitive, and just push our probes into parts of the waffle board, and we shouldn't see any numbers on the screen. If we see some numbers on the screen when we are probing the board, then it means that it's conductive and we have to cut that section out. But so far so good. I think this board, we got lucky and it hasn't carbonized to the point where it's conductive. There was a number there, I just touched my probes together, so that's fine. So yeah, looks like we got away with it just there. But we did lose the small trace here for the... we did lose the small trace. Where's my tweezers? Where's my tweezers? Here they are. Yeah, we did lose the trace for the gate resistor. So you can see that's come away there. It's just kind of like flying up in the air. So we'll have to just use some jumper wire to go from there to the gate. No problem. There to the gates there. That's fine. We should probably snap this off because it's just like sitting there doing fuck all. Just getting in the way and may fall off and cause problems. Let's get rid of that. And because we're going to fit 3205s on the power supply, I'm going to use 47 ohm gate resistors instead, because 47 ohm gate resistors are better suited to the 3205s. So now that we know that nothing is conducting on the board and it's not leaking, etc., I'm going to plug some power into this thing, and we're going to check the drive waves on the power supply gate. Yes sir, yes sir. I'm just going to check which one is the positive. So it's either that one or that one. So it's going to be this one. This one's our positive input. So get our positive wire from our power supply. Speaker Free Code 2, how's it going, yo? Look, the stream looks fine tonight. The stream is fine. So, you know, the other night, my my OBS was dropping out, was dropping balls. Every flipping 5 minutes it would drop out. I think that was a YouTube server issue and not an issue my end. It was on a weekend, so it was probably super busy. So I reckon that it's fine. So my computer is now fine. It's where OBS is using 45% CPU, etc. Seems fine. But I still do need a better PC, and Speaker Free Code 2 is massively helping me out with that, so huge thanks to Speaker Free Code 2 for all your assistance so far. I need to actually sit down and look at all the parts that you've sent me, the list and stuff. It's been kind of crazy busy today getting things finished, but I will do that very shortly. Now I'm just going to solder the remote onto the board because I can't be bothered to have it keep falling off all the time. My PC is most likely not keeping temps low. Let's see how hot my CPU is currently running, rendering this live stream. It's running at 77 degrees. Not too bad. I did turn the quality down a little bit though, so. Okay, so I've soldered my remote cable on there just because I can't be bothered for it to keep falling out all the time. Drives me nuts. Come on, work out. There we go. So let's turn this jam on, and let's see what our drive waves look like. I'm gonna give her 10.8 volts just to be on the safe side. Wow, this thing drew no current on the power supply capacitors. Literally no current at all. Okay. Interesante. So let's go before. Now we need to remember we need to go before our gate resistor because our gate resistor is blown. So if we go after our gate resistor on the pad, we won't see anything. So we need to go before our gate resistor, which is just here, and we need to see, are there any waves? Are there any waves? Rejecting frequency, turn that down a bit to like 5 volts, turn that up, there we go. Okay, doesn't look like we're getting anything at all actually, there. So it doesn't seem like we're getting any drive wave there at all. Oh, wait, I see, aha! I see something. I can see clearly now. So yeah, it seems that this pad is actually pretty in bad condition, so I need to push down quite hard. Okay, that looks like a nice drive wave. That looks pretty decent. Okay, let's roll over to the other side. Let's make sure the other driver survived as well. Yeah, that looks pretty good. Let's make sure that they're both the same amplitude. So we go to that one first. I pause the scope. I go over to the other side and I activate the scope again, and the amplitude should be exactly the same, which it is. Perfect. Cool. So drive circuit for the power supply has not been damaged, which is very surprising given the condition that the FETs were in and the gate resistors were in. So cool, that's fine. What I need to do now is before I put the power supply FETs in, I need to remove the shorted output FET on here. So we've got a IRF 9540, sorry, over here. Oh, that's driving me flipping nuts, that is. It's never doing that normally. So we've got a damaged 9540 FET just here. So you can see that this has a direct short circuit between pins 1, 2, 3, and 4 and 5, and every single pin is shorted on that one. Yeah, the one next to it is fine. So it's possible that the 540 survived, but we should probably replace both of these at the same time because these will be quite old batches and we need quite new batches. The other side seems to survive just fine, so we can leave the other channel hooked up. Now this is quite useful because we have a 2-channel amplifier here. Essentially we've got 2 amplifiers. One seems to have survived and work, and the other one is obviously blown. So it's very useful because we can use the side that survived for our reference to take measurements from, diode reading measurements and resistance checks and other things. So if we're struggling with something on this side, we can go ahead and check over on the good side to see what's wrong, which is very useful. So I'm just going to go ahead and remove this dead 9540, and then we can plug the power supply, put some new power supply FETs on, and see what else is going on here. Cow Too Big says make sure you check the gain pots as they go bad from the wrong screwdriver. Ah yeah, the tiny pissy little gain pots. They look pretty good. like condition-wise, visually they look pretty good. But I hear what you're saying. They are those pissy small ones, so that's a good shout. Thank you. Yeah, so let's go ahead and get this thing out of here. I just turned the I didn't actually turn the soldering iron on. I just turned the fume extractor and I forgot to turn the actual soldering iron on. This thing heats up in like literally seconds though, so I've had that on for what, like less than 10 seconds now, and already it's melting the solder on the tip. I love it. I love things that respond fast. I ain't got time to be sitting around and waiting. I'll need a rag because this is going to be pretty hot when I remove it. Or should I just man it up? There we go, manned it up. Alright, there we go. Okay. So what other things have I fixed then? Off of live stream. So I don't live stream every single amplifier I repair because I'd never get anything done because it takes flipping forever. So I've actually been working on it on a B2. I've been working on a B2 audio 0.101, I think it is. Nice amplifier, very good power. And those all died from vibration damage. All the output FETs, they snapped their legs. The amplifier would never have died if it wasn't for vibration damage. So many amplifiers get killed from vibration damage. It's an absolute nightmare. Literally a good 70% or more, probably more, of the amplifiers that I get in the workshop have died as a result of vibration damage. So if you want your amplifiers to last a long time, if you don't ever really want to have any issues with them, generally amplifiers will take really good abuse. Like the majority of amplifiers will eat up clipping, will eat up low voltage with no problems. The issue is vibration damage, and that's what kills the majority of amplifiers. Whether it shorts the inductor, whether it snaps legs, yeah. Yeah, fume extraction is flipping and really important, guys. Really important fume extraction. Muy importante. I'm just browsing through for some spare power supply FETs. Yeah, I'm going to use some ones that came from an old amplifier here. Ooh, I could use 1010Es. I got some spare 1010Es here. That might work. Let me see what the 1010E is all about. IRF 1010E. Let's have a look. What does the 1010E look like? I've only because I've got some spares of these. With these small amplifiers that only use like 2 or 4 FETs in the power supply section, I try and use up some of these old FETs that I have like a small handful of, because otherwise I never get to get rid of them. So these are 60 volt and 84 amp, and how easy are they to drive? Let's have a look. Yeah, the pulse train looks pretty high on these. Nice. Gate charge is a little bit high. Not mad high, just a teeny bit high. Should be fine. The input capacitance is where's that? Here we go. Input capacitance 3210. Again, kind of higher than some, but not too bad. Not horrific. Okay, no worries. Yeah, let's use these. Why not? And we're going to use, I'm going to use some 47 ohm gate resistors as well. It's not far off the original. I don't have any, 68? I don't have any 68s. And it won't make that much difference. After replacing the output transistors, is there any need to readjust the bias current? Yes, possibly. Yeah, absolutely. Especially where the original MOSFETs on the outputs, because this Class AB uses MOSFETs on the output section. Because they were made so long ago, the specifications of the new ones I fit may be slightly different. So yeah, it will probably need rebiasing, but we'll know that for sure, because when I power this up, we'll see whether it heats up, whether it heats them up or not, and see how much current the thing draws. Hopefully I won't have to rebias it, but you know, I'm fully prepared for the fact that I will. I hate seeing myself in this camera view, because I'm sort of leaning over like this. I look like flipping Hunchback of Notre Dame. Okay, cool. So that's the FETs fitted. So now we need to remove the old gate resistors. Make sure that they work. And I think I've got some 47 ohm SMDs. I've got some what have we got? Some 220 ohm. These are 47s, but they're tiny. There's some slightly bigger ones if I can. These are 22.1. These are 34. It's a bit low. These are 1100. These are 10. What else? 4.7. 510. 3.3. Come on. I must have some 47s in here somewhere. Oh, I've got one 47 there. Actually, that might work out nicely. Because, I'll tell you why, because I might actually need to, on this one that died, this one where the pad was damaged, I might have to actually run a through-hole resistor. Although perhaps not this one. This one looks like I burnt it from discharging some rail caps, so let's choose a different one. Nice little box of old spare resistors in here. Here we go. There's one that might work. Okay. Hot air station ready to go. Camera doing its bitchy thing again. I think the only way to fix that is to actually stop the live stream and start it again, which I don't want to do. That's long. So remove this gate resistor first. Just heat up. I'm going to just preheat the sort of small general area around this board first a little bit. I don't want to popcorn the board. So what happens if you have two different MOSFETs on your amp? What do you mean? You should never use two different FETs or even two different batches in the same parallel bank. Some amplifiers will need two different types of MOSFETs on its output section if it needs P channel and N channel MOSFETs. Especially if it's a Class AB using MOSFETs, it will need two different types. Yeah, so this one over this side, I'm actually probably going to replace that one with the through hole resistor because the trace was damaged. So because the trace was damaged, I can just put the through hole resistor through the hole and then solder the wire to the leg itself. Imagine that, putting a through hole resistor through a hole. What is he doing? Go. I'm not gonna lie, this resistor is massively overkill. It's flipping huge, but it's the only one I have spare at the minute, so we're gonna roll with it. Yeah, gate resistors, you can use a bigger gate resistor than needed, a bigger power rating. It doesn't matter. Put that there, and then we're just gonna bend. Oops, I'm gonna bend this leg so that it lines up with the gate, like so. Get that down there. And then, there we go, looking good. Now we just need to solder that to the gate. Yep, there we go. I'm just going to freshen up because that's the original solder on the bottom here for the leg of this resistor. So I'm just going to freshen that up a little bit. Freshen up, and then cut that off. There we go, good. And I only had one remaining 47 ohm SMD resistor, which is handy because I can use that on the other side where the trace actually survived. So that's over here, maybe. Where are we? There we go. This camera is very disorientating to use. Freshen up the solder pads. And drop this baby in there. Siete. Okay, let's make sure that that trace is actually intact and it is actually connected to the gate. It looks a little bit funny. Yep, connected to the gate. So we've got 47 ohms between there and there. And so then we also should have 47 ohms between here and here. Ah, stank. Oh, wait, there we go. Yep, 47 ohms between there and there. So I'm testing between the actual driver transistors themselves and here, so yep, looks good. And then this one over here also looks good. Nice. Wow. Yeah. Okay, cool. Let's put all these resistors back in my box. And now we can put some power. Some very small power, because this is only a very small board, so I'm going to turn my current limit very, very low. How can I repair a horribly burnt PCB? Got an amp that partly works, but sorta doesn't, because I tried to replace a cap using a blowtorch. Holy fuck. Ah, it's only a base phase DB 1.1. So what do you mean by partly works? What works on it and what doesn't work? if you burn the PCB and it's conducting, you need to cut that section of the PCB away and run new wires, new traces, new jumpers. Out of Memphis, the output driver board IC number is scratched off. How do you figure out what it is? They're only very common parts. It's probably an IRS 21844S. Yeah. If it's got, can't remember how many legs that's got. I think it's 14 legs. It's like a rectangular chip. I can't remember how many legs it's got. IRS 21844S is very common. Some amplifiers don't use that. They use an 8-legged IC, or a pair of 8-legged ICs, or a trio of 8-legged ICs, which will be a 072C and an LM211 or 311. What are the ones? Maybe a IR2010, depending on the size. So yeah, send me a picture to my Bearvidge Facebook page and I'll be able to tell you what it is based on its size and the circuit that it's in. Okay, power time. Let's see if this thing works. Okay, it doesn't draw any current on idle, which is good. So I'm literally only going to allow 0.7 amps to pass, because it's such a tiny board. I want to make sure that everything's good when we power it up. If it draws more than that, then there may be an issue somewhere. So let's go ahead and probe the drain of our power supply FET to make sure that the power supply works. Okay, wow, there we go, very nice. So power supply drive looks good. And let's make sure that the actual gate drive looks good as well. Make sure our gate resistors are the right size, etc. Yeah, the gate drive looks very nice actually. That's really good. That was a good match to put these 1010Es with 47 ohm gate resistors. That looks great. Okay, awesome. So that's all working well. Now we need to go ahead and take a look at the output section. So we've obviously got one channel here that potentially is working fine. So let's see what our rail voltages are on the output section. Just for reference point, this amplifier on idle is drawing 0.4 amps, which is fantastic. There's nothing at all. Okay, so our rails are negative 19 volts. Negative 22 volts and positive 22 volts. Great. So we should have, if the drive circuit is working properly, we should have our positive and negative rails on the source of these FETs. So that's on the good side. And we should have our drive, which will be a little bit lower, down at 19 on the gates, which makes perfect sense. Because that's just low enough for it not to be switching on, and then when the thing actually does audio, it turns it on. So let's have a look on this other side. So we've got our 22 volts on the source. So on the gate we should have negative. We've only got 10 volts on this one. Okay, so it's possible the driver transistors there is possibly a little bit fucked. Or maybe it might need the FETs in place to do it properly. So let's see the other one. 22 volts on the source, and the gate has 22 volts on it as well. So yes, the drivers are most certainly fucked on this side. Pepe Demon, can you help me with my question? What is your question, my friend? Yeah, so I'm gonna go ahead and take a wild guess that the driver on this side is fucked, because we should have, source with negative rail, which it does, drain with nothing, and gate with like 19, which has 10 on this one. This one we've got source with positive rail, which we have. Drain should have nothing, which it does have, but the gate should have again 19, but instead it has the actual rail. So it looks like we have some shorted parts that we need to look at. Now let's take our I doubt anything is going to be heating up on the board, because it's only actually making use of 0.4 amps. So if it was anything was heating up, I would have thought that this no, actually things do heat up. I was going to say I would have thought that it would draw more current if things were heating up, but apparently not. Oh wow. Okay, so this LM 337 is getting pretty warm. Do they both get warm to the same amount, I wonder? I wonder if that's a voltage regulator. What's the LM337 doing? This could be a driver. This has negative 12. Ah, yeah, this is a 12 volt regulator. So any component that's dropping voltage across it will get warm. So the LM337 is being used as a voltage regulator. So it's dropping. Yeah, it's dropping the rail voltage from 22 volts down to 12 volts. So obviously that 10 volts that's disappeared has to be emitted somewhere, and it comes out the board as heat. So that's why those get hot. The power supply FETs are staying dead stone cold, which is nice and good to see. So let's use our thermal imager and have a look and see, are the drivers heating up? We've got something getting crazy hot over this side. That appears to be... what's getting crazy hot over here? Something's getting to like 50 degrees. This is a really shit thermal imager, so it's very hard to see, and it's crazy out of focus as well because it's not designed to look at things that close. It looks like it might be one of those resistors. Let's compare it to the other side. So on the other side of the board, nothing is getting hot. So a working channel should have nothing getting hot, and this side has something getting pretty hot, up to like 50 degrees. So yeah, that's something we need to look at. So I wonder if it looks like it's coming from this resistor maybe. It's so hard to make out. This is some piece of rubbish. I need to get myself a better one of these for sure. Yeah, it looks like it's coming from this resistor, which would make sense. If we've got rail voltage where there shouldn't be rail voltage, then that might get hot. So if a resistor's getting hot, it will be dropping voltage across it. So let's see if this resistor is dropping voltage across it. So on the start of it, we've got 22 volts. On the other side, we have 22 volts. Okay. On this one, we have negative 22, and this one we have negative 22. Okay, so it's not the resistor. Let's take some alcohol. I'm going to spray some alcohol on the board, and I'm going to see where the alcohol evaporates from first, and that's a good indication as to what's heating up. So it's over here, and that's somewhere this section. So spray some alcohol over here, and let's see what evaporates. Where does it evaporate from? Okay, it does seem to be the resistor that it evaporates from pretty quickly, and the A56 drive transistor it also evaporates from pretty quickly. Okay, cool. So we've got an A56 and an A96? A06. I think that's an A06. I don't have any A06s, which is really annoying. Yeah, it's an A06. That's frustrating. So I don't think I necessarily will be able to repair this tonight because I don't have any A06, I don't think. That's kind of annoying. Let's remove them anyway. Let's remove these potentially dead drive transistors, and let's see whether that heating goes away. Hi, Chris. I have to remember which one goes where. So, whoops, that's kind of hot now. So the 56 goes next to the power supply, okay. Okay, so they have been removed. So let's see if removing those causes our heating to go away. our central board heating. Let's see whether it causes that to go away or not. Okay, still drawing the same amount of current. So let's see what we have on each of these driver pads. So we've got -12 and +22 on these two. Let's compare that to the other side. The other side should have okay, the other side shouldn't have -12 on it. Should have 19 and then nothing and nothing on this pad. What the fuck? Okay. That doesn't seem right. So what's feeding the drive transistors? Could also be this one on the end here. It's possibly this one on the end. This one on the end here. You see this? This little one. This is possibly the final driver because it's on the heatsink, so it gets hot. So this has 12, 12, and 12 on it. Whereas it should have, looking at the good side, it should have nothing, nothing, and nothing. So why does that have 12 on it? So something's giving 12 volts to that shouldn't. Okay, let's go back to the good side and compare the good side. Let's see, all these very small transistors here, these will all be part of the drive circuit. So let's see if we can find where that 12 volts is coming from on the good side, because then it will show where it's leaking from on the bad side. Where's the source of the 12 volts? It could be actually the actually, too, it might be a good idea. Actually, the good idea might be to check that the good side is actually good. So let's it's not heating up, but let's check that it is actually outputting some audio. So I'm going to plug some RCAs in here. We're going to turn it on and just see whether it actually does some audio on the good side. To check that it is actually a good side and that I'm not referencing something that doesn't work. Predict high frequency. Okay. Ah yes, so we do have audio on the good side. So the good side is the good side, and it is good. Okay, good. That's good. Okay. So yeah, we have audio on the good side. As well. Okay. Interestingly, the gates don't actually really do anything. It's kind of weird. The audio, there's not really any audio signal anywhere on this board. This class of A, this type of class AB, I am not hugely familiar with, I have to admit. So this is all kind of a bit of a guessing game so far for me as to where, because this isn't a class D, so there's no drive waves anywhere that I'm used to seeing. As far as Class AB is concerned, I'm used to just following the audio signal through the board and seeing where it's different. But on this one, because it uses MOSFETs, on the gates of the MOSFETs, we don't have. There's no drive. It's not like there's a drive wave. It's almost like the audio signal goes to the drain of the MOSFET, and it uses the voltages on the gate and the source to amplify that to the output, perhaps. Ah, here we go. Some kind of drive wave here. Okay, so there. Okay, that makes sense. So there should be a drive wave on the center leg of that, but when it's all in circuit, it doesn't end up actually being there. Weird. Okay. So we do have a drive wave on the center pad of these drive transistors. Interesting. So I wonder why when it's all in circuit it's not present on the good one. See that? It's just like 2 volts DC. Really interesting. I wonder whether this side is actually working, and I'm just gonna let it apply some small. I'm gonna give it a small load to drive. I'm gonna give it a 47 ohm load to drive. So if I find a spare 47 ohm resistor, and I can put that on the speaker outputs. And if I put that on the speaker outputs, then I can give it a small load to drive. Yeah, see, look, there's tiny audio signal on the drain of the bad side. See this? A tiny audio signal on the drain of the bad side. That must be how it works. It must send the audio signal to the drain of the MOSFETs, and then that's kind of how it works. Alright, let's apply a load to the good channel. So doing that increases the current draw a tiny bit. Let's make sure the drive the wave still looks good on the bad side when we apply a load. Yeah, it still looks good. So the good side is still working fine. Alright, wicked, no worries. So what I'm going to do now is I'm going to fit some new drive transistors to the bad side. I'm going to see if I can find a spare. I need an A06, so I need a spare A06 transistor. Just have to see if I can scrounge through some donor boards. See, all these use 2N, 2N5551, 2N, etc, etc. I don't think I've got any spare A06s. I'll take my transistor tester and just measure these transistors and see what they read. See if any of them read anything bad. Okay, well the A56 reads as a PNP, as it should correctly in the board. The A06 reads as an NPN, but the HFE is possibly a little low. Okay. So I don't know if they're actually dead. I don't really know. Look at my drawer of old drivers here. See, this is where I'm far less experienced with this Class AB stuff. I can do you a Class D any day. The Class AB stuff is just, it takes a little more working out for me, especially when it's a MOSFET Class AB. I'm just going to steal some parts off of this board quickly. This is a US amps. It's a piece of crap. This is one of the new US amps. 3K board is actually rubbish. Not very good amplifiers. So I'm just going to steal a couple of the A56 off this board. See, that's the thing. I don't know. I will tweak the gain pot and see if the issue goes away. But I don't know if there's an issue yet. That's the thing. I don't know if there's an issue yet. The board, the circuit could be giving me all these weird voltages because it hasn't got all the parts in. I've had that before with these kind of weird circuit designs, especially with Class AB. It needs all the components in to actually show you the correct voltages everywhere. So I might actually just try putting all the parts back in and seeing what happens. Ouch! That's hot. Okay, so this is an A56. This is a brand new one. That's fine. So I'm going to measure this one and compare it to the one I just took from this Rockford board. HFE is quite low, down at 115, and the emitter current is 6.1 milliamps. Okay, yeah. So this is actually probably fine. So the A56 is probably fine, and I wonder if the A06 is actually also probably fine. I'm going to just take a quick guess right now that they're probably fine, because they do read fine on my tester. It doesn't always mean they're fine. The tester doesn't always get it right, especially with these small transistors, but I'm going to go ahead and take a guess right now that these are maybe okay. And we can check that they may be okay because there was something getting hot over here though, which wasn't getting hot before on the other side. Okay. I'm going to put them back, and I'm going to see, because there was a drive wave, wasn't there? Did you see the drive wave on the pad? So I'm going to put these back in. I'm going to see whether the drive wave is still there when I put some audio into it. Maybe it will be. Maybe it will be. Alright, so I've just put those drive transistors back in. I'm curious to see where the drive waves are, where they go to. So let's power this back up. Team Peronoka sends me €2, DD for life. Thank you very much for that, buddy. Thank you very much for the kind donation. Yeah, Didi for life. Yeah, I do love Didi. I have some issues with them at the moment. Not them. There's a few things that I wish that they would sort out, but I still like Didi. Okay, power up. And so let's see what happens. Aha! See now, those drive waves end up on the gate. That's cool. So that is actually correct. This thing is working fine. So I'm learning now how this thing works. Cool. So maybe it's fine. Maybe it just needed the fetch replaced then. So yeah, without any FETs in the board, it does do the thing. It does actually work. It seems to work fine. I believe it works fine. We shall find out, won't we? Because I'm gonna fit some new FETs just now, and we're gonna see what it does. So the original FETs that this needs is IRF 540 and 9540. I don't have any of those. I only have 640N and 9640. So what I'm going to do is I'm going to quickly take to Digital Designs. So what I'm going to quickly do is take to Google and see what the differences are between these parts. Because I can't remember what the 540 is like. Compared to the 640N. Okay, so the 540 is a 100 volt part. It's a 100 volt, 28 amp. The 640 is a 200 volt, 18 amp. So I was right. I guessed earlier that this was going to be a lower volt part, but higher current. Okay. Negative 100 volt part. So, okay, what I need to do now then is I need to dig through my selection of FETs here and see whether I can find something. I'm not going to have a matching P channel that's minus 100 volts. I'll tell you what, just to test it for you guys, just to confirm that it works, I can drop a 9640 and a 640N. It's not the right part, but it should work just for this test. It should show up whether it's going to work or not. So if I drop a spare 9640 and a spare 640N, the voltage is too high and the current is too low, but at least it will tell me whether it's going to work or not. Yeah, most brands have things that they're generally good at. So that's a 9640, and let's find a spare 640N. Got one just here. Really nice. Muy bien. What's that? I guess I would pronounce that name Pera. Hang on, Pera is the good. Or no, it was the A with the 2 dots. Is that a long? I didn't tell you what my big fuck up was. No, I'm possibly too embarrassed to tell you. Can I use my phone mic input to tune my gains with a resistor and an oscilloscope app? No, I would not recommend doing that. You would need some flipping high value resistor to. So you guys keep getting the stream is offline because fucking OBS keeps dropping out again. It's been fine all evening and it started dropping out all of a sudden. I'm not too sure why, so apologies, but it's an issue my end. Yeah, if the stream keeps going offline, it's not your end, it's my problem somewhere. Got some issue somewhere. Just trying to find out what the issue might be. Heronurka means furthest corner. We have had this name for over 15 years. It suits well for car audio as the pressure wants to build in the furthest corner. That's pretty cool. I like that. That's a really cool name. Anyway, because I think this may be repaired. So let's see. Let's turn it on and let's make sure it still draws not much current. I'm still only going to let 0.7 amps pass. Ah, nice. So it's only drawing 0.3 amps still, and these are not heating up, they're staying dead stone cold. And so I have some signal input obviously here. So if I turn the amp back on, this is the good side. This is the side that was working fine. So now let's check this side. Yay! We have audio. We have audio. So it was fine. The driver transistors were just fine. So we've got 3.2 volts there. And 4 volts there, so the gain positions will be different, which they are. So yeah, this is repaired. Good job. Didn't need to do much. So in this amplifier, all we did was we changed. I'll say what we did. All we did was we changed the power supply MOSFETs, the gate resistors, and the 2 output MOSFETs over here. That's all we needed to do on this one, and she's fixed. But I do need to. Yeah, so yeah. Cool. Successful repair, motherfuckers. Yeah, this would be a headache to repair if there was more wrong with it. So it really depends. Every amplifier repair is different. It's never the same issue twice on an amplifier generally. So if more of this section had been damaged, you can see there's lots and lots of very tiny drive transistors in the board here. So if we go over to here, you can see there's lots of where are we? There's lots and lots of very tiny SOT23 surface mount components. So if any of those had been damaged, this would have been a more complex repair. Luckily, they were fine, and I only had to change the output FETs here and the power supply FETs. So this wasn't too bad. Cool. Okay, I need to go. Yeah, the stream, literally, the stream keeps cutting out. I'm not too sure why. So apologies. Apologies for that. I only seem to be able to get... Ah, here we go. IRF 540. These are not cheap. £1 each. The 540N is a 33 amp part. 540 is a 28 amp part. Voltage regulator from there. Don't think I need to order that anymore. Okay, so these parts are going to cost me 12 quid. Pepe Demon, I'm going to link a video to you. Because I can't bother to get all the... Okay, so Pepe Demon. I'm just going to link a video to you now in the live chat. So if anyone is interested, this is the video for the clipping detector. Cool.